Great. Okay. It's sort of 5 past now, so I think we've given people plenty of time to sort of join the session. So basically, what we're going to sort of cover in this session is looking at integrating and securing workloads between a sort of VMware Cloud on AWS SDDC and EC2 workloads. And the reason I thought we'd sort of cover some of this is I've come across a few customers looking to do this, and I think the likelihood of customers wanting to leverage this capability is going to increase as time goes on. And whilst there are a number of sort of blog articles and sort of posts out there about this, I've still come across a number of customers kind of struggling, and generally it's very small, silly things that are sort of catching them out. So I thought it might be good to just do a kind of a bit of a walkthrough, talk through of what this looks like, in the hope that this will be useful for people. So with that, we'll get started. So I guess what this is really about is if you were to go and sort of read the sort of VMware Cloud and AWS website and kind of look at what one of our descriptions of what that is, you'll sort of see it here on the screen. I'm not going to read that out because I'm sure everyone's perfectly capable of reading. But what I wanted to really sort of focus in on this session is the part that sort of optimized access to AWS services. Now, optimized is perhaps a little ambiguous, perhaps not entirely clear. So, as part of this session, what we'll actually do as well is we'll talk through what that access looks like and how you can go and see that for yourself in your own AWS accounts. And it will help, hopefully, that will then help you kind of understand how that integration works and help you then implement that and or sort of troubleshoot if you're having some sort of difficulties. So, with that, um, one of some of the sort of topics we're going to cover in this session is we'll have a sort of general overview of what that integration looks like between VM Cloud and AWS and sort of AWS VPC and EC2 instances. And specifically, we'll sort of focus in on some of the ENIs from the ESX server hosts, what the routing looks like from the VPC, and some of the sort of the IAM roles that support that capability. And then what we'll do is we'll sort of go through some sort of examples of what that traffic flow looks like between the two. What I've got here is I've got a number of slides. We can cover it all with slides, but hopefully I will be able to sort of do some of this live on a lab environment. But of course, I've got some slides here to back me up in case the demo gods are not on my side today. So I'm sure anybody that's been and viewed a VMware Cloud on AWS session has probably seen this slide. It's probably in pretty much 90% of the sort of VMware decks that are out there. And this is obviously sort of conceptually highlighting the integration points to VMware Cloud on AWS and some of those capabilities. Now, obviously, the key part that we're going to be focusing on is that direct access to the native AWS services. And so, as part of that, we'll talk in a little more detail of what this actually looks like. So the capability we have is that direct access to the native services. Now, I want to kind of emphasize, and you'll see some of the descriptions on VMware websites sort of calling that out as free data charges to those examples. And I want to really kind of caveat that point in that in the correct circumstances, the charges for that data flow between an SDDC and your AWS account can be free. However, that is restricted to connectivity within the same availability zone. So just be careful about doing that. And obviously, for anything outside of that circumstance, the standard AWS charges are going to apply in terms of data transfer, whether that be cross AZ charges or cross region charges as well. So I just wanted to make sure that's clear. The last thing I want is sort of people setting this up, finding they get a large data bill, and then sort of coming to me saying, "Hang on a minute, you said this was free. Why have I got a bunch of charges for this?" Um, excuse me. And so this capability really is kind of enabled through the account linking, which any of you who've set up an STDC, you'll have gone through that process. There's a couple of questions that we go through, which essentially links the steps that link the STDC to your AWS account, and in particular a VPC and subnet. So what does this look like in a little more detail? So if you were to sort of break this down and kind of try and look at this from from a slightly AWS perspective, what you've got is the VPC itself. So you've got your AWS account. Within that, you've created a VPC, and ultimately a VPC represents an isolated virtual network. Now, that is kind of constrained to the single region within AWS, and then that VPC and that subnet that you've specified is sort of subdivided. You subdivide that down into a series of subnets. So, and you'll recall when you go through the setup process for an SDDC, you have to specify the VPC, and then you also specify the subnet that is used for deploying the SDDC. And what that's really doing under the covers is essentially defining the subnet where what we call the cross VPC ENIs are going to get essentially connected to. So each of the ESXi server hosts within an SDDC that's deployed has a cross VPC elastic network interface or an ENI, and that connects to that subnet that's defined. And this is kind of, I guess, the connectivity mechanism that is being used to provide that direct access to the AWS services. And I guess one of the things to sort of call out as well is it often comes up on a slight tangent, but it comes up with a lot of customers is around the sort of shadow account where the SDDC is deployed. I just want to make sure people are clear that that is not a multi-tenant account that is shared by multiple customers. So you as a given customer are going to have your own shadow account. So let's dive in and sort of take a look about what this really looks like from within AWS. And if you log into your sort of account, what are you going to see, and what is that really going to look like? So what I'll do at this point is I'll actually sort of dive into the AWS account and sort of show you it live. So if I just stop sharing the deck. Now, hopefully, everybody can sort of see my AWS account here. So what we'll do at this point is we'll go and take a look at, here we're sort of already logged into my AWS account, and we can see the EC2 dashboard. And so we talked previously about the ENI adapters for each of the ESXi hosts. So what I thought I'd do is if we come along and show you where those sit. So within your EC2 dashboard, if you would come to the network interfaces, what you'll then find is a list of all of the ENI adapters that are in use within your account. So, and what you'll see, these are obviously clearly labeled as VMware VMC. And I guess a really key point I want to call out is in that name, we label it do not use. And that's clearly been labeled that way for a reason, in the sense that we've had customers have problems where they've tried to sort of reconfigure or attempted to delete these interfaces. And so obviously that's going to break some of the functionality of your SDDC. So please sort of stay away from that. You'll also see a long sort of GUID here, and that would represent and correspond to the SDDC ID for your particular SDDC. Now, you'll also probably notice that among these ENI adapters, there's a whole series of them deployed. Now, in the case of the SDDCs being deployed, people are typically deploying, say, like a 3-node SDDC or a 4-node SDDC, or maybe a 6-node in a stretched cluster. And so, but you'll notice, and in this case of this demonstration here, we've actually got a 1-node SDDC that we're really using, but I still have those 16 ENI adapters that have been essentially pre-provisioned. And if you were to go to a sort of a cluster that was larger than that, then further ENIs would be provisioned as part of that process. So you'll also see all of these ENI adapters, they're all defined to a specific VPC and a specific availability zone. In this case, everything is in US West 2A. And this is a good point to look for if you were linking to any EC2 workloads. and wanted to double check you've got everything in the same availability zone, this is a very quick and easy way to do so. So you can see everything here is in that same AZ. Now, another key point that's worth noticing as well is the security groups. You'll notice that all of the adapters, if we sort of filter by those, all of the ENI adapters are all members of the default security group. Now that'll become, just sort of stick that in your memory, and we'll sort of come back to that point and why that is significant shortly. Another point that's worth sort of bearing in mind is you'll see of all of these ENI adapters, only one is in use. Now, you'll recall I just mentioned this particular lab environment is a one node deployment, but you would actually observe that irrespective of whether it was a one node, a three node, a four node, or a six node stretch. And what that really kind of corresponds to there is all the kind of connectivity in and out of the AWS VPC will go through the compute gateway firewall, which runs on an NSX edge device. And that edge device, that whilst it's a pair, one of those is active at a given point in time. And so what that in use is corresponding to is the host where that edge device is running. Now, you may also notice there's a secondary private IP there, and again, that corresponds to that same edge device that's running on that particular host. So that's not. I know some customers have kind of looked and sort of said, "Why is only one of these active?" That's as designed. So don't see that as a cause for concern. So next, what we'll sort of move on to is if we were to look at your VPC. And what will be worth looking at now is the main route table. So this is the VPC in question in the case of this lab environment. And if we were to click on that route table, you'll see the main routes in place here. Now, this is sort of pretty standard for AWS. So what you're going to see by default for any given VPC, you will typically see a route for the subnet for your VPC to local. So essentially that's providing routing within your VPC. You'll also see one for essentially other addresses, which would then by default go to your internet gateway. So these two entries here would be default for a given AWS VPC. Now, what you'll notice that's perhaps a little different is the following three entries below. So what we have is a subnet here, which is for the SDDC, essentially. So what you would see, depending on whether you were running NSXV or NSXT on your SDDC, you would likely not see this route here if it was an NSXV data center, because that capability to route to the sort of management components is not there in NSXV. What you've got further down is you see we've got two Class C subnets, and these are corresponding to two network segments that have been created within my SDDC. So if I were to just flip over to the SDDC and just show you where that is, you'll see we've got two networks have been created. You'll see the same two subnets. So in the process of those networks being created, those additions to the main route table in the VPC are being updated for you automatically. So that's giving you the high level concepts as to how the connectivity looks like from the host, how the routes are implemented within AWS for traffic to flow between the two. Now, one of the questions you might sort of ask yourself is, how is this getting updated automatically? Well, as part of the creation process for the SDDC, you would have essentially linked it to your account, and some additional IAM roles would have been created. So I'm not going to spend a huge amount of time on those, but just identify that if you wanted to come and see where those were in your AWS account, you would see a series of roles as we do here. Now, you'll probably notice in my particular account, I've got 6 additional roles here, and this is clearly because I've had a prior SDDC that I've not cleaned up particularly well. So, but what you'll see in here, if you were to look at one of these roles, you can then obviously then go and explore the detail of what permissions and what capabilities that has within your AWS account. So you as the AWS account owner, you have the full ability to see exactly what the VMware, those VMware created roles can do within your account. Also, if you were interested, if you were to look on your connected VPC area of your SDDC, you'll see here the roles as well defined that have been created. So with that, let's move on to sort of starting to look at what the actual connectivity really looks like and setting that up as a worked example. So one of the first things we're going to need to do is configure some connectivity on the sort of the compute gateway firewall. Now, you'll see I've got a couple of rules I made earlier for one of those particular subnets. And what we're going to do is sort of step through the process of sort of defining some of those rules. So, for example, if I were to connect to this particular virtual machine here, which you'll see is connected to network 2, for which I don't have any rules at the moment, then if I were to attempt to ping a workload within the SCDC, sorry, within within AWS, then clearly that's just not going to work because we've got no rule permitting that traffic to leave the SCDC. So what we'll do next, I'll edit these existing rules just to keep things a little tidier. Now, whilst I'm doing an inbound and an outbound rule, I guess I just wanted to call out that the compute gateway firewall is a stateful device. So it's not that you need inbound and outbound for sort of return traffic to flow. It's more for if you want to be able to initiate connections in a specific direction. So if you have a particular use case where you only actually need to connect outbound from the SCDC or vice versa, then you only actually really need one of these rules. So if we were to now sort of return back to this particular virtual machine, and we try a ping, now we see that's working. Now, this is where it's kind of important to understand how your AWS and your EC2 instance in AWS has been created, and the method, I guess, the way in which that's been created is really going to sort of heavily impact the security group that was assigned to. So, for example, that was just one of my workloads that I was pinging there. Now, if I pick a different one that was created in a slightly different way, we shall probably find that that would fail. So if I test to this workload here, we'll see that that's failing. So what I'll do is I'll just jump back to some of the slides at this point. So where we've got to is we've gone through, we've added the equivalent of the additional rules required to permit the connectivity in and out of the SDDC. And we've done a couple of test pings, of which one was successful, and we've then observed another one that has failed. Now, what we didn't do, and we can flip back to do that now, is if we were to do the equivalent ping from the opposite direction, So this one on this particular EC2 instance is failing. Whereas if I were to go to the other one that we did earlier, we would probably find that should find that is successful. And so what we'll do next, we'll sort of come on to why one has been successful and one has not. And the significance really comes down to the configuration of the AWS security groups. And this is what I tend to find with some of the customers I've worked with is actually the configuration part of the SDDC to permit the traffic in and out from the VPC is relatively straightforward, and most people sort of find that pretty intuitive and get that pretty quickly. But I've seen success on the AWS side to more or lesser extent, depending on the customer. So what we'll do before sort of diving back into that in the actual AWS console, we'll just cover a couple of key topics around AWS security groups. So most of this should hopefully be fairly sort of self-explanatory and fairly obvious to people in the sense that in terms of defining security groups, they're similar conceptually to sort of firewall rules. So it goes, it should be no surprise that the source or destination for a security group can be an IP address or a CIDR range or actually, and I guess this is one of the key points, another security group. So that's probably one of the sort of key points I've sometimes seen missed by customers in that they're doing everything by CIDR ranges and specific IPs and not recognize that you can actually use a security group as well. Obviously, when you do use that security group, it applies to all of the instances that are members of that security group. But a key point to take on board here is that it's going to apply to the private IP addresses, not any sort of public IP addresses or any NAT addresses or anything of that nature. So that's just sort of one to watch out for that can kind of catch you out. And I guess another key point is in terms of AWS security groups, you don't specifically set like a deny rule. Essentially, everything you do is an allow rule, and if you get essentially it's sort of overlapping rules or rules that correspond to the same service, then the most permissive rule is going to be applied. So it's just concepts to bear in mind for when you're working with security groups, such that you don't confuse yourself. Now, another thing to sort of think about now, and I mentioned this earlier, is how was your EC2 instance created and how did it end up with an associated security group? So there's a number of different ways that this can happen, probably an infinite different ways, depending on to what extent you do or don't use AWS services natively. So, for example, if you were to just go and create a new security group, what that would look like is essentially it would have an outbound rule allowing all traffic, which is the default, but there would be no inbound rules at all. So all that's going to happen for any workload in that EC2 workload in that security group is it can pass traffic out, but nothing will be accepted incoming into that workload. Now the default security group is very similar. It has that same outbound rule allowing all traffic, but what it will also have is an inbound rule from itself, essentially. So meaning that workloads within that default security group can all talk outbound, and they can all essentially connect to each other within the same security group. Now, and this is where sort of the last point, this is where I've seen it sort of catch a few people out, is that when you run through the EC2 creation wizard, unless you go and select a specific existing security group or essentially assign it to the default group, then you're going to get this new one created, which will typically have the name of like launch wizard n, n being the number depending on how many workloads you deployed. Now, those are again sort of similar in again that you have the outbound rule allowing all traffic, but you will also then have an inbound rule that allows access to a given service, whether that be SSH or RDP, and that's typically dependent on the type of AMI that you've deployed. So obviously a Windows server is probably going to have an inbound RDP rule, whereas some form of Linux box is going to have SSH inbound. So if we were to sort of drop back out of a PowerPoint and look back at AWS, sort of run through some of that. So what you'll see here is, so with the default security group, by default you would have all traffic within the security group. So this is the ID for the default security group itself. Ignore this particular RDP rule. That's one I've added on top of the default security group. So that would not be there by default. You would have to add that yourself, and then outbound rules to anything else essentially. Now, in the example of what we've essentially got is the VM where we had that successful ping between the STDC and the EC2 instance was an EC2 instance that's a member of this default security group. And if we come back to this rule here, remember I called out earlier that the ENI adapters for the ESXi server hosts are members of that default security group. So essentially, but by having them all in that same security group, this rule here is allowing that communication to occur. And this is what I've seen a sort of fair amount of some of the existing articles that exist on this topic essentially just say, have the workload in the default security group and you're done. Now, that may be acceptable for some use cases, but there's often a lot of cases where people already have predefined security groups, or they want to do something a little different, and that's just not going to work for them. So we also had the example of the workload where the ping was unsuccessful. And that was an example of where this is a new EC2 workload that's been created, just literally done a next through the process, and we've ended up with an EC2 workload that is in a launch wizard security group, which would be this one here. So, and what you'll see in this case, as we were talking about on the slides, by default, there's an RDP rule being added because it's a Windows instance, and there's an outbound rule here for all traffic. So the challenge we've got here and why that connectivity is not currently working is obviously there is no traffic. There was no rule here to allow an inbound connection essentially from one of the host ENIs. And equally, one of the things we don't have on the default security group as well is any sort of inbound traffic from that launch wizard instance. So the way we would sort of kind of go about rectifying this, if we were to go to the launch wizard security group, we can edit these rules. Now I'm going to go with the sort of sledgehammer approach initially of just allowing all traffic. From the default security group, and if we save those rules. So now in that case, if I was to come back to my Windows instance, and we should see that ping now works. So essentially permitting that inbound traffic from the default security group to that launch wizard one that was assigned to that EC2 instance by default is essentially obviously allowing that traffic to pass. But we would obviously still find if we tried to do the reverse that traffic still doesn't work. And so if we go back to our security group, what we'd need to edit, as I mentioned previously, there is nothing permitting that traffic from that launch wizard security group assigned to that instance to the default security group where the ENI adapters for the hosts are running. So what we can do okay, so hopefully that's sort of kind of fairly self-explanatory. as to sort of what needs to sort of happen to get the connectivity in place. And this is normally it's just these small updates and configuration changes on the security groups that I tend to see kind of catches um, most people out when they're trying to configure um, this sort of setup. So flipping back to the slides, we've sort of talked through um, essentially why the sort of examples of those connectivity tests using a ping did and didn't work. So we had the EC2 instance in the default security group. As we called out, all traffic within the default security group itself is permitted, and so that was essentially that is why that connectivity succeeded, and that is what I've seen a lot of people do just to kind of get it working. And this is a good way to assuming it's permitted, if you're having some connectivity challenges, you can sort of temporarily test, assign your workload to that default security group. And if that works, then you know that your connectivity problem is either related to a security group problem, or typically a security group problem, or maybe something on the SDDC side. We talked about the EC2 instance in the launch wizard group, and we called out that there's two reasons why that was sort of failing, one for each direction. The access to that group from the default security group, and also then the access, the sort of permitted rules to the default security group from that launch wizard. And we sort of talked about why it didn't work from the SDDC. So moving on. So what we've done sort of there, we sort of talked around this very much being everything I've done sort of so far has been around sort of all traffic. It's very much been a very much sort of sledgehammer approach, and definitely not that would be deemed acceptable by many of the sort of security teams. So sort of a couple of things to think about is obviously typically certainly from my perspective, if I see any sort of firewall really that has an any in it, then it's probably too permissive, and it probably needs to be reviewed and locked down a bit further. Unless you have a very relaxed security posture, that is typically the case, and it's obviously not very much a good practice. I imagine anybody that kind of has any kind of security audits or reviews by their security teams, I can pretty much guarantee that the first thing the security teams are going to look for is any rule that has any in it. So obviously, pretty much now that we've sort of gone through the overview of kind of getting that initial connectivity working, it's just a process of now going through and sort of locking these rules down and refining them a bit further. So, for example, let's start replacing the any with specific services. It's common sense, really. Look at replacing perhaps specific entire security groups. You can do that with a specific subnet side or a specific IP address entirely. So you could take, for example, those launch wizard groups. I would replace those with something that's more meaningful. So perhaps a web server group. I guess one of the key words of caution, again, that I'd come back to is just be cautious when you're doing anything with that sort of default security group, as you don't want to impact the host DNIs themselves. So what we can also do here, for example, I've got a couple of, here's some I made earlier. So here's an example of another EC2 instance that was deployed, deliberately did a next deployment going through the launch wizard. But what you'll see here, I've essentially taken that any rule away, and I've allowed HTTP only. So if I were to now go to my VM and connect to that particular VM with a browser, which should be this one here. you'll see that's connecting to my web server 2 in that, and just to sort of prove that I haven't kind of made that up, we do a local host on here, you'll see that's the same instance. Now equally, what I won't be able to do from one of these VMs is do a ping. You'll see I'd set up a specific rule here for sort of ICMP, but only from this specific virtual machine here. So if I were to go to this VM here, so I obviously can't ping that VM because there's no rule there, but if I were to, I can obviously sort of get through on port 80 because that's been defined there as a rule. Now, if I go back to the other virtual machine where I can still go through on port 80, but I can also obviously go through on a ping. So again, hopefully this is, none of this is really sort of rocket science, but I thought it's a useful sort of walkthrough for those that have not done this before. So key things you can do is obviously lock it down by a specific IP. In the case of AWS security groups, you have to sort of do it in the CIDR format. What we could have done here was do that entire subnet for the network 2 that I have in place. And obviously it's just a process of now going through and refining the rules to meet your needs. Now, what we haven't done at this point, this is everything we've sort of talked about here on the AWS side, is obviously we can do exactly the same from the compute gateway side. So the way I sort of tend to think about it is you've got an entry and an exit point on both sides of this connection between the SDDC and an AWS. So again, depending on your security posture, you could control most of that from one side, or you can lock that down at both sides of that connection. Most of the customers I've tended to work with have tended to do that sort of from both sides, because the AWS sort of VPC side of things and the SDDC tend to be managed by sort of different teams, so they both have their own sort of set of standards as to how they do this. So, for example, what we could do here, we could obviously just edit these rules. Take the any out, otherwise that's not going to. So then what we should be able to do is then obviously sort of validate that. So you can see I was successfully connected to the web server on the VM running in my SDDC, but we would then should find that if we were to now try and ping that virtual machine, then that's not going to work. So we've got sort of full control from both sides in this context. So what I thought I'd do now, we'll just do a kind of a quick recap of some of the sort of concepts we've covered, and then sort of hopefully leave a few minutes for some questions in case anybody has them. So we talked about the account linking and that offering like a low latency, high bandwidth access to the AWS services. Again, just want to re-emphasize that the charges are only free when the workloads are within the same AZ. And any scenario other than that, and then standard AWS data charges can apply. The host ENIs are members of the default security group, so do not sort of edit, modify, sort of delete the ENIs themselves. Otherwise, you're sort of likely to find yourself on a support call for VMware, and as much as they're lovely people, I'm sure you don't want to be breaking your STDC. We talked about the main route table being updated automatically. So again, that's another area as well, is you have full control and full access to your AWS account. So I would strongly recommend you don't go and remove routes from that main route table either. Otherwise, you're going to find problems with connectivity, which is sort of hopefully should be fairly obvious. And essentially, you just work through, you configure the compute gateway to allow the traffic to and from the linked VPC as you desire. The compute gateway, as we talked about earlier, is a stateful device, so you don't need to allow inbound and outbound specifically. It just depends on which way you anticipate you'll be establishing the connections. And then typically with the security groups, depending on how it's, there's so many different combinations as to how this can be done for different environments, but typically you're going to need to allow some form of inbound traffic from that default security group, and also the inbound traffic to that security group from wherever the EC2 workloads you're running are placed. Now, I thought I'd call out a couple of sort of troubleshooting tips that are sort of useful for people, and I can probably dive back into the AWS console to show a couple of these. So obviously, check the firewall rules on the compute gateway. We've not really sort of touched upon it in this session so far, but obviously with NSXT, you've got the distributed firewall. So depending on how that's configured, you could end up with a situation where a DFW rule is potentially blocking connectivity from a VM in the STDC, and you're spending a lot of time looking at the compute gateway or the security groups thinking that's the problem, when actually it's the DFW. So I think it's important when you're implementing the STDs to think about a clear strategy in terms of where are you going to control and restrict which types of traffic. So for example, north-south traffic you would be looking to do through the compute gateway, whereas east-west you perhaps focus on the DFW for that access. Another one that's really easy to fall foul of is the guest operating system firewall. So if you deployed a standard AWS AMI image with Windows on it, it is almost certainly going to have the Windows firewall enabled, and that is going to block and prevent you doing sort of any pings between the virtual machines that you're working on, unless you go and either disable that or add a rule, again depending whatever works for your standard and your security posture. The VPC routing, I've certainly come across it where I've been sort of playing around in the sort of VPC trying to figure out how stuff works, and I've gone and deliberately deleted a route, forgotten I've done it, and then clearly that's not going to work anymore. So again, check that the routes that you expect are in place, and if one of those are missing, it might be that you need to sort of find out what's happened there. Another good one you can do, if you've kind of gone through all these steps and you're still stuck and don't quite understand why that connectivity is not working, you can set up flow logs in AWS, and that will give you an indication as to how a particular flow is being blocked, whether is it being accepted or dropped by a security group. So to give you an example, if we go to so in this case, I'd set up some flow logs, and I just had it drop them in S3. There you go. So you can either drop them in S3, or you can also view them directly. Give me 2 seconds. What I'll do is I'll pull up an example of one I downloaded previously. So you can see here, for example, here's where I was using some flow logs to try and diagnose a connectivity issue I was having. So you can see that I've successfully initiated a ping from this address, that source address, this destination. This protocol ID will relate to ICMP in this case and the number of packets. And the key thought here is you can then see that there's an accept and an OK. So in that particular case where I was having a connectivity problem that wasn't working, I was sort of struggling to figure it out. This sort of proved and showed to me that the security groups were absolutely not the problem. And it turned out the challenge I had was one with the main route table in my VPC. So that's another useful tool in the event you're sort of struggling to figure out why your connectivity is not working. So lastly, to wrap up, there's a couple of references. So we'll obviously sort of share this content as part of the webinar. Useful articles to read certainly is data transfer charges. I'm sure I've probably mentioned that enough times now. Sort of VPCs and subnets and security. These are all really useful just to understand how everything works on the AWS side of things, which is sometimes less familiar to people who've traditionally worked more with VMware technologies. So I think on that note, we've got a few minutes left at the end. So all that's left is for me to sort of thank you for your time and thank you for coming and listening to me, and allow you a few minutes to ask me some questions. I assume everybody can unmute themselves and ask questions if they have them. Everybody's extremely quiet. Okay. If there's no questions, I've sort of come to the end there. So I have sort of nothing more to say really, unless there's anybody wants to ask anything specific or wants me to go back over some of the content from the session. Oh, there's somebody coming up in chat. Yes, I believe we will be sort of posting the recording. So yes, that should be fine. Are you guys able to unmute and ask, or are you having to ask me through chat? Okay. Well, I guess if there's no further questions, I'll happily sort of hang around for the next few minutes in case somebody has one. If not, we can sort of probably end the session there.